Morning. Welcome to Experiment 8 explanation. So today we are going to learn how to use a simulator for Raspberry Pi into a PC using a software called VirtualBox. And also, if time permits, we will see how to run the simulation of Raspberry Pi into a software Proteus. So let's start with this experiment. I will share the screen. Okay, so first of all, we need experiment 8 write up. I will just take that from the classroom. So I think for other batches it is already completed, so I will take it from B1 batch. Go to the classroom. Experiment 8. So this is the experiment where we have to study how to install Raspberry Pi OS onto our computer so that we can run a small simulator of Raspberry Pi into a VirtualBox. And second is to study how to interface RPi and TFT. For that version, for doing this, we need a cracked version of Proteus. So let us see whether we are going to perform it today or not. So let us start with the software VirtualBox. I think there will be some link given to you. So this is a Raspberry Pi. You'll learn about it maybe next Monday or something. By the way, today you don't have a lecture at 2:30 because of the MTech orientation program, 2:15 to 3:15. I will put a note accordingly. So let us start. First, we need to download the virtual box. So let's go to this particular link. So this is to download the Raspberry Pi OS. Now to save the time, I have already downloaded it, but for your convenience, I will just show you. This is how it looks like, Raspberry Pi for desktop. So those who are using Windows, they can use this. Even it's supported in the Mac version also. So you have to click on the download button, and it should download roughly 2.9 GB file, 2.87 GB file. Uh, Now for your convenience, I will just do one thing. I will give the link to this particular setup file from my drive. You can download. So I think industrial electronics. You can download either this or you can get it from the internet also. I think this should able to allow you to download. Okay. So in case there is an issue, you can directly download it from the web itself. Uh, and I will also share you the write-up file for this experiment.
So the access for the drive is not given.
Okay. Experiment number 8. Yeah. Okay. So in case you are not getting access from the drive, you can directly download it from the website itself. I will just give that link also to you. Okay, so this is the first step. You can start downloading this 2.8 GB setup. Next step, what you have to do is you have to download the virtual box, which is a simulator where you can simulate this Raspberry Pi. So you can directly use this link. And I will also paste this link to you. So here you have to choose something called as Windows host, or you have any other OS, you can choose accordingly. It will download a 103 MB virtual box for you. I have already downloaded it, so I may not waste time. And once you download, you have to install this virtual box. So this is how a virtual box will look like. Initially, we will not have any operating system. So right now I have already installed, so I just delete it. So this is how your fresh virtual box will look like. And now you have to click on add. If you have already any virtual box, but in our case we are creating, so we have to click on new. Let me name this as Raspberry Pi 3 or something like that. Here you have to change the type to Linux and select Debian 64. So this is what you select. Click next. Now typically Raspberry Pi has a 4 GB RAM, so change it to 4096 instead of 1024. Click next. Internal memory card for Raspberry Pi can be from anything from 8 GB to 32 GB. So I am using 8 GB. Create virtual disk. Choose VDI. Click next. Dynamically allotted. Click next. Here you give some location. So C drive user Ninar VirtualBox MS RPi3 VDI. Create. And the disk is now created. Now next step is we have to give the CD drive to this virtual machine. So either go to the settings and then choose something called as uh, drives. Let me check. Controller storage empty. Okay, I went to storage, then chosen a controller empty, and now I will click on this icon and I will ask for choose a disk file. Wherever you have downloaded, mostly in downloads, the ISO file, select that and click OK. So now everything is set up, and now you can turn on your Raspberry Pi. Click on start. Okay, now here if you click on run with persistent, it will directly start the Raspberry Pi OS, but it will run through the CD. If you need to install it on your virtual machine, you can click on graphical install. Oh, so it got timed out, so it is now running directly from the CD. That is also okay. When we designed this experiment, it was not there, so now this is a new thing. In exam we might ask you to install, so let us understand that also. Now here you have to click next. You have to choose country. It is very important. Same menu you will get when you start your Raspberry Pi. After installation you should see all these things, and I will explain commonly in class how we do that. Then language, you can choose whatever, and time zone select perfectly. Use English language, use US keyword, click tick. Now always remember, by default the password for Raspberry Pi is Raspberry and username is PI, but if you want to change you can do that also. You can set your new password. It's always better to uh, remember the password and keep a common one. Then yeah, this is a very important step. So whenever you do a new software setup for Raspberry Pi, please update it, otherwise you will not able to learn many of the libraries. And sudo apt-get update and sudo apt-get upgrade are the two commands. If you don't get this menu, then you can do it offline also, but mostly you can update by clicking next. Right now I will skip, otherwise it will take long, and then your setup is complete. So why did I keep? Because I am not going to perform or make any robot through this Raspberry Pi. I am just writing two simple programs which should be easily running with the existing setup of Raspberry Pi. So this is your Raspberry Pi virtually running. It's a single credit card size microcomputer which you can use in your robots or mechanical designs or many things. And to run this machine, we need a Python coding. So let us write two simple Python codes to get started with. The first one is obviously hello world. So to get familiarized with IDE and how to run a Python code in Raspberry Pi, click on this Windows like button, Raspberry button, and then go to the programming and choose Thonny. So Thani is the Python IDE inside a Raspberry Pi. It is very similar to your Windows IDE, what you get on the Windows. And if you don't want to install a virtual box, you can get Thorny for Windows also and switch to its Raspberry Pi mode, which looks like this. So here, let us write the first code. Again, the codes are given in the write-up. Let me just show you where they are. So we have installed Raspberry Pi and run our first Python code. Now this is the installation procedure. We have selected new, then we have selected Linux, Debian 64, whatever is the path, chosen the RAM as 4 GB, then created a virtual hard disk of 8, you can choose 32 GB also. Then you allot the size as VDI file, then go to the properties, go to the storage. Yeah, again they have selected number of processors. So Raspberry Pi can have one processor or two CPUs, so you can change the system processors to 2 if you want a faster execution. And then you can go to the storage, select empty, click on choose virtual disk, and then load your Raspberry Pi file, and this is how it should start. So when this post was created, we go to the graphical install that I will show now at the end. You select British English, and the next steps are already given as a screenshot. You can follow them. Right now, we will just directly reach this point. So we skip lot of steps in between, and then we click on next, and now we are in this code 1 where we want to print hello world. So
Sir, why
print.
did we install it in a VirtualBox? Is there isn't a like a standalone app that we can install on Windows? What was the
Um,
need of
so
installing
it's a
installing it
simulator
on?
for Raspberry Pi OS. Raspberry Pi is a ARM controller, and ARM OS are not standard x86 or x64 OS. So if you want to run Android or Raspberry Pi OS, you need to have a virtual machine which is configured as ARM machine. If you want, you can install this entire x86 program as your main OS of your computer also, because Raspberry Pi is basically meant for ARM OS. So even if you see you cannot run your Android OS onto your computer, you have to have its simulator. So similarly, we are using a VirtualBox simulator for this ARM OS. So now this is like a mini Raspberry Pi running on your computer. If you have your actual Raspberry Pi, you can connect it to VMware. I will explain all those things in our lecture next Monday maybe. So how to do it practically, we will see that. Today we are just learning the simulation. So there is no app available. Even you will see the Proteus will not give you to Raspberry Pi OS. So till now there is no app. There is a lot of need for it, but it's not available. So there is no Raspberry Pi simulator or something like Raspberry Pi OS, which has a front-end GUI. Your cracked version of Proteus do come with Raspberry Pi templates, but it all block code, so you don't do actual Python coding there. Now today we are going to do two codes. first one is hello world. So I will just type hello. Let me type my name, and then you just run the code. Very simple code, and you can display something like this. It will ask me to store the code file, so you can write code.py and store this file, and it should display hello Ninat. So this is your first print screen to be taken. Second code is actually a blinking of LED, but again you have to understand that we are simulating. We don't have a physical GPIO pins where you can blink the LED. So that's why most of the part of this program is commented. Let us start writing this code also. What I will do is I will set it as a half windowed screen, and let's start typing so that you understand line by line coding. So first line is import. Now again it is asking, it's a case sensitive language, so don't change the casing. So it is saying rpy dot gpio as GPIO. Now there are two ways in which you can configure this GPIO. So generally your GPIOs are floating and you get a warning about it. So you have to turn the GPIO warnings off. So next line is GPIO, okay, dot set warning, and then you have to say false. Now if you don't do that, you will get an warnings, nothing else will happen, but it's a good practice to set the GPIO warnings off. The next very important instruction is GPIO dot set mode. Now here you actually configure what your GPIO should be. There are two options. Either you can go for BCM, that is the actual GPIO names, or you can go for GPIO board. I personally like GPIO board because it is a physical layout. I will just explain you what is this, what does this mean. So if you go for Raspberry Pi pinout, and let me just see. You should see something like this. Now if you closely monitor this diagram, you will see this GPIO2 is written in front of pin number 3. So in Raspberry Pi you have pin 1, 2, 3, 4, 5, 6, 7, 8. So all odd number pins on this side. This is a physical Raspberry Pi, and all odd number pins are this side and all even number pins are on this side. So if I want to connect something on pin number 8 over here, then if I choose BCM, I have to write URTX. Okay, so its functional name I have to mention. If I want to use pin number 12, physical pin number 12, I have to write GPIO 18. So that is what happens when you write BCM. You have to use these namings in your program. But if you write board, and now if I want to blink something on physical pin 12, I have to write 12. So that is the difference between board and BCM. So that's why I generally ask students to directly go for board. Don't think of this because they are not in sequence also. See here 2, 3, 4, then 5 is missing. Then 17, 27, 22. So there is no logical sequence. These are actual physical, what you can say, Broadcom pin numbers. So that's why these are named like that, and they are grouped as per the ports, but we don't care. We directly go for physical pin numbers. But remember, if you go for GPIO board, you have access to the pin number 2 and 4 also, which is the power pin. So remember, you don't have to use any of the power and ground pins. You can use any other pin other than this power and ground pins. So you should not use 39, you should not use 34 when you are in board mode. When you are in BCM, there is no question like that. So that's why it's always better to go for a GPIO board mode. Next command is, so I have directly came to GPIO mode. So I will set pin number 8. Okay, now this is a physical pin 8 on the board. GPIO.out initial value to GPIO low. Now I have missed one command at the top, that is import time from sleep. So I will just take that because that will allow me to create a delay. So I will do import time, from time import sleep. Import sleep. So these are the two ways in which you can import library functions. First you write import and get everything from that library, or from library time import only a sleep function. So you can get only a part of that library. Why this from command is there? Because sometimes you don't need the full library, you just need sleep function out of it. So you can only import that much of function to save the memory. Now let us go ahead. The next line is GPIO setup. So first one is set mode, and now GPIO dot setup. Here we have to mention the pin number. Now it is physical pin since we have chosen a board mode, comma. Then you have to say whether GPIO input or output, just like your Arduino. GPIO dot out. Okay. Then comma uh, initial equal to. So you can give the initial value GPIO. Okay, if you want high, you can write dot high. If you want low, you can write dot low. But make sure that everything is in capital. So this will set up pin number 8 as output pin, and it's set its initial value to low. The next command is, now setup is done. We will blink the LED. So I will write while, then it's continuous blinking. So I will say true, and I will start the loop. So whenever in Python you start the loop, you don't have to give curly bracket open close. You can directly start with space or tab. Now here it has already created tab for me. So that is the advantage of Thorny. So as soon as you open a loop, it automatically creates a tab for you. So first thing I want to set is GPIO dot output. Okay, and then I say pin number 8, comma GPIO dot high. So this will turn on the LED. Then next thing is I will also print it because I cannot see the output in this simulator. So I have to say LED on. Next is I will wait for 1 second. So in the Python you don't have everything in microseconds. So I have to write sleep 1 to indicate it 1 second sleep. So everything is in seconds in Python. Then same 3 lines will copy paste because we have to do the same thing again. So I just copy and then paste, and here I just have to set it to low, and then LED off. Okay, again you wait for 1 second. So this is the code for LED blinking in the Raspberry Pi. Since we don't have physical hardware connected, if I try to run, though this code is absolutely correct, it will throw me an error that GPIO not found because there is no physical Raspberry Pi connected. So RPi module is not found, GPIO is not available, all these errors. So that's why you have to put this hash, which means comment those lines. I have to comment. See, since I don't have Raspberry Pi physically connected, I have to comment this line, GPIO related all lines. And then also I have to comment the actual pin LED blinking line. And now I should see the running code. So LED on, LED off, LED on, LED off. So these are the two codes and two outputs you have to take. Now let us go back to the write-up itself. So the next part is we have to observe our own picture on a TFT display. That part we might do it in the later part of this lecture or maybe next lecture. Now we will learn how to install the Raspberry Pi OS because last time we skipped it and directly started the machine. So let's go back to the virtual box. I will just shut down this existing Raspberry Pi, and now it will come out. So now we are back to the Raspberry Pi 3 machine. You can click on start and it should bring you to the your first selection menu. Now I will go for graphical install, click next. Now here you can choose any language, click next. It will detect the CD-ROM. It will load all the components. And this is exactly what I was showing. Use British English, then it will come to this, use guided entire disk, and all these menus will pop up, and you have to select the properly what I mentioned in the write-up. So let me just check. Yeah, use the guided disk, click continue. Use this 8 GB hard disk, all partitions, finish partitioning and write the changes to the disk. Here you have to change it to yes, remember this. And now it will install the Raspberry Pi OS. So this is the experiment, and now we have to click next, 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 and complete the installation, and it will boot the Raspberry Pi. So with that, I will stop the recording, and if you have any doubts, you can ask.